All right, I guess we're live now. Okay, so Facebook kills off Oculus, even though it tries to brand itself as virtual reality. All right, hold up. What the fuck is this? Despite a name change and that its existing brands wouldn't be changing, our company's now Meta. I still think it's kind of funny. They'll be killing off the Oculus brand. All right, fair. I mean, Oculus was like definitely a cool project, but it's just like my question is, well, I mean, it's pretty obvious. Like Oculus wasn't like doing anything. It's like a great experimental brand, but it's just like, what the heck are we going to do with it? You know. So my question is why. Actually, I want to see this blog post actually. Our org will become Reality Labs, and our work is. I'm guessing that they take like Oculus's mission, and just kind of like make it more expansive. So yeah, the Reality Lab. I think that's really it. AR to VR to Facebook Reality Lab is a way to encompass the expansive work that we do. I guess it's just the same work, just rebranding it, and they just kill a brand. Yeah. So the Oculus brand is just going to be killed in exchange for Facebook Reality Labs. That's it. So I understand that. So it's just really the brand that dies. It's fine. I don't think there anything substantial changes here. Let's see what else is new. Zales.com leaked customer data like sister firms Jared K. Jewelers did in 2018. Do I want? I'm not sure I want to read that one. That one's a. Ooh, Apple reports fourth quarter results. Let's actually see. Let's actually see this. Yeah, September quarter up 29% year over year. Sure. Services and Mac revenue reach all-time highs. Blah blah blah. 83 billion, up 29% year over year. Holy fucking shit. This is awesome. This year, we launched our most powerful products, M1. We're infusing values, looking carbon neutral, blah, 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 and down to supply chain. Our record remarkable fiscal year of strong double-digit growth, which set a new record revenue in all our geographic segments, blah, blah, blah. The combination of our record sales for unmatched customer loyalty and the strength of our ecosystem, yep. $20 billion to our shareholders. Yeah, fair enough. Cash dividend of 22 cents, payable, blah, blah, blah. All right, I want to see what the let's look at the consolidated statement. I think this could be pretty interesting. Yeah, like these numbers are kind of fucking insane, even though you consider like coronavirus numbers. Like, I would say at the very least, coronavirus numbers were like, if I do it off the top of my head, maybe 5-10% underneath what they were doing before. So like. The fact that they went from 220 to 297 is fucking insane. This is like in net sales for products. This is absolutely ridiculous. Holy shit. I still think they can sustain this growth. This is actually kind of nuts. Cost of sales. Yeah, okay. It's just supply chain issues raising this price. I get it. But it's still more than offset by the amount of products that they what's it called? Sold. This number here, I'm very happy to see. Research R&D, investing in yourself. Yep, I like seeing this. Capital expenditures. Selling and administrative costs. Usually, I'm not too fond of this. Usually, Apple doesn't need to sell itself. But I think it's okay. I'm okay with the operating expenses increasing like this. 10-15% year over year. Why not? Operating income. All right. I don't need to see this. This one's cool. Net income. Yeah. When your net income goes fucking double, like... This is actually kind of crazy to me. Like, you increase from 0.74 to 1.25. This is more than 30% year over year. Like, I don't know why people aren't like going fucking crazy over this. This is actually phenomenal numbers. Maybe the market, I think, is just pricing it in as a yeah, maybe market's already priced in this this growth here. That's probably what I would guess. So number of shares. Yeah, they're still buying back a shit ton of shares. I kind of want to see quarter to quarter buyback shares, but my guess is that they bought back a lot in Q3. Actually, let's take a look at that. I'm curious. Hold up. So Apple Newsroom, blah, blah, blah. Let's see. Apple Q3 earnings. let's look at this one. If I had to look at the consolidated statements for the shares, I want to see how much they're buying back. Hold up, guys. Let me change the title of the stream. Cool. Cool. Okay. So we have this. Let's actually look at the reports side by side. Actually. So I put this here and I put this here. Yeah. So here's the Q3 on the right, and then Q4. Yeah, Q3, and then Q4 on the left. So you see here, like they bought back what, 200,000 shares? Yeah, about 200,000 shares out of 16 million. So if we did the math on that, 200,000 divided by 16 million. So they bought back like 10% of their fucking shares. That's actually kind of, that's like, yeah, that's like 12% of their shares. That's really freaking insane. And then we look at, like, say, the price action. So Apple stock for the past quarter, if I had to guess here. So let's say it's from June to here. So yeah, basically you're gonna attribute like 12% of this growth to the buyback, I think. So yeah, let's say it's like huddling around 123, right? 12% of that is gonna be like 135, and so for it to sit at about 142 would mean that it's, I guess, it's pricing in the 300. Yeah, I don't know. I feel like at 145 is like bare minimum, but like 152 is still pretty good. I still think they're kind of underestimating what Apple is doing. Regardless, let's go back to the, yeah, like when you buy back 10% of your fucking shares in a single quarter, I still think that's pretty fucking nuts. Net sales reportable by region. All right, let's take a look. So in Americas, they went from 30 to 36 in the 3 months end. Pretty great. I have no complaints about this. This is what's surprising me. It's that they doubled in fucking China. Holy shit. Like, I expected actually this to be smaller. I'm actually so surprised this ended up being so much bigger. So like if we look compared to the year before, or the quarter before, like you go from like 5,000 here to like 6.5K. That's like 15% growth. The fact that you double in a single quarter, you're like at 3 months is actually kind of, it's crazy. That's crazy to me. Here, take a look at the 12-month period. Here, you go from that's like a 50% gain. I think this is like highly underestimated. I would not be surprised if we see in like 3-5 years that China region actually accounts for as much as the America region. Look how close it is to Europe. Like this is pretty great. Yeah, and if we just do this as a percentage of the revenue that they're getting, like imagine if you boost this number up by like $14,000. That's like 25% right there just in products alone. I think that's entirely feasible for a region like China. Net sales, iPhone. I think most people were like considering that iPhones were stagnating in sales. So I'm actually kind of happy to see this. Yeah, I'm actually pretty bullish on this. Whether or not this is the right price, I need to do another check on. But I think personally, looks really, really good. Like it's a really strong company. Whether or not it's the right price is a different question. Assets, cash equivalents. Yeah, I guess cash equivalents hasn't really changed much. I see they actually increased their cash equivalents. Wow. Yeah, you look at this from quarter to quarter. So you have like this $900, or to say 900 million over here. Marketable securities stay the same. I don't care. Accounts receivable, I don't care. Inventory. Okay, so inventory kind of went up here. All right, fine. Net liabilities, shareholder equity. This is kind of like what I'm more interested in. 40 to 54, 42.296. Okay. I think this is fine. This is fine. Net debt. I think this net debt's gonna be interesting here. They increased their debt by like what, $1 billion here? Yeah, I think that's really it. I like this number. I honestly don't care about. This is nothing. Um, term debt. Okay, how much of this term debt is due? That's my question. Oh, well, 109. Okay, whatever. Okay, yeah. So the buyback, like buying back 12% of your shares in a single quarter is actually kind of cool. Blah blah blah. Adjustments to cash generated by operation. Okay, fine. Yeah, proceeds from issuance of common stock. Okay, so they issued more shares overall this year. Okay. Yeah, honestly, I'm not too disappointed by this. I actually am completely fine with this. Why like the market took a huge dump on it is a bigger question. Maybe they just thought it's overpriced, but let's see what the Hacker News. Let's see what Hacker News says. I'm actually really curious, like what people really think of the stock. But I'm personally like bullish on this. I would probably buy the dip, at least for me. But net cash neutral position. That cash isn't doing much. Growing cash neutral here means this instead of uselessly adding to our cash reserves, we're going to aggressively dispose of our revenue. Okay, dividends, share buybacks. I mean, from an investor standpoint, it doesn't really matter if the cash sits in a pile or it's paid back. I think it doesn't really matter because it's all a cash flow to equity anyway. Blah blah blah. Yo, contract Intel. I don't give a shit. Nope. Let's see, Apple maintain a cash reserve. Yeah. Yeah, I remember this one. Microsoft literally bailed out Apple. It was kind of funny. 2018, $6.2 billion. Most of my dividends. I don't give a shit about dividends. It doesn't matter if it goes to cash or it goes to a company or it goes to investors. A little bit should go to investors, but it doesn't really matter. Okay. Recent split no account. I don't care. Blah, blah, blah. Cost of products went from 70% to 66%. Yeah, I mean, you make everything in-house, it will actually increase your profit margins. So 4%, increasing your profit margins by 4% from now till forever. What? That would be discounted, like, that's an additional 10% of growth? Yeah. I think that's kind of interesting. But, yeah, gross margins and increase in service sales. Yeah, I think the sales is actually kind of crazy. I don't know. Yeah, y'all people who are like fucking like shitting on Apple, like no. This company's gonna be around for a really long time. Anyway, we have 2 minutes left. I'll take questions from the crowd if y'all have anything to ask me. Your code displays Japanese wrong. Ah, ha 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 ha. Unicode. Oh god, I fucking love dealing with this shit. When you're doing Android, just for context, one of the things you really need to keep in mind is the locality of your users. And the reason why is because, like, for instance, something that reads like left to right on your phone, is going to read like right to left in, like, say, Arabic. And this is a pretty common problem with like a lot of international apps, as well. So it's kind of, I'm curious to see what they says here. Ooh, this looks kind of funky. Okay, kanji. Okay, this is probably a short dive into linguistics. For instance, here are the Japanese, simplified Chinese, and traditional Chinese variants of the same character. Okay, sure. Therefore, if the text in Japanese is displayed using a kanji glyph set meant for other languages, they look pretty bizarre. Okay, fine. If you use the traditional Chinese word in relation to the Japanese word, it's gonna look weird. Fine. Han unification was made to create a single unified set of Chinese characters. Sure. Oh wait, it's actually pretty close to coaching time. Hold up, guys. Let me actually call my client.
Recording in progress.
And let me download his replay. Give me a sec. Cool. Okay, so he sent over the replay. That's good. 45 minutes. Okay. Let's see if he joins. Should be joining the chat anytime soon. Oh, Sean asks, curious, what's the equivalent of box model? What's the equivalent of box model in Android? How do you align center position things, and how do you deal with right to left example that you talk about? So really quickly, while we're waiting for, you would usually just use it as part of a text view. So text view usually just takes care of this for you, and you would just do like a center. You would just center aligned on this. And so you, in theory, if you had the text take care for you, it would be fine. But what most people do is that they just like force the gravity to the left. I would say that for the most part, I know this is not like a very good explanation of things, but yeah, just try to have your view handle it. Yeah, and we're gonna go through replay analysis. Anyway, hey Russell, or yeah.
Hey Edbert, how you doing?
Hey, doing good, doing good. Yeah, so we had a coaching session on Monday. Told you to work on a few things. Tell me how that went.
Yeah, so I went to try out a couple problems on the array section. I also did a practice interview with my coworker yesterday. And in general, I think like I wasn't. So in the past 2 days, I haven't been able to, because I was really trying to go as like slow and not just like not give up, like you said. So I pretty much like spent like a long time on like some of the problems, so I wasn't able to go through a lot, because some of the problems like in my practice diary I listed like I spent like 45 minutes or like maybe an hour. And you know, usually if I reach the like 45-minute or like a 60-minute mark and I couldn't really figure it out, that's when I actually look at the solution and see what's different, like what they did do and what I didn't do. But I think in general, like I was like taking it really slow. And with the practice video I sent you, I practiced it on the spiral ordering because I feel like that would be a good one.
Yep.
And it really took me like a whole hour. Like I feel like in general I just like was pretty slow in like coming up with the solution or like fleshing out the details. Like I think like the idea would come to mind pretty quick. But then in terms of actually fleshing it out and expressing my idea was not easy, and so I was just generally like pretty slow with a lot of the problems. But I feel a little better in terms of like walking through my idea. I feel a little better in that, but like I said, it's just pretty slow.
Okay, that's fine. Yeah, I pulled up your sheet here. Don't give up. Really try going through as much examples. But yeah, right. Don't worry. You'll get faster at this as time progresses. Like it's only been 2 days, and you only done like a few problems anyway. But you'll get the hang of it once you start going through the examples. You'll understand what exactly is needed and what unnecessary steps you're doing. But now I'm curious about like the interview you did with your coworker. My question is, well, what was the feedback this time?
So I actually did it with a different coworker this time. So the question he gave me was basic calculator. So basically a string, given a string, and then I have to evaluate the entire string.
Yep.
Parentheses are allowed, and then plus and minus. So no multiplication, no division.
Great.
So this time, I really like tried to analyze the problem like slowly. I used a couple examples, but if your question is what was the feedback, I think I actually did a good amount of walkthrough. So he said like, you know, he really liked how I spent a lot of time talking about my ideas and actually like listing it out in terms of like I provided like good examples. That was one thing he said, and then I proceeded with testing the pseudocode with an example from start to end. I wrote the code after getting the green light from him, and then after writing the code, I also took a example to run through my entire code. So yeah, he thinks that I spent a lot of time clarifying a lot of things, which was good, and doing a lot of walkthrough. But I think like just because I feel like that problem is more like even though it's string, it's more stack based. So I was a little more comfortable and I was able to get through it a little faster than other types of problems.
Fair. I think that's okay. But like you said, it's what he appreciated was how thorough you were about analyzing the problem before you committed yourself to code. And I think that's something that we were talking about like last week. Run through your idea before you write the code for it. That's literally what we tried talking about, like, and keeping your explanations very simple and short. And it seems like he literally picked that out and said, "Hey, you did good on this."
I think the thing I really felt like I improved on was you know how you talked about showing the call stack?
Yes.
And I think like when you were showing me how you did it, when you had like an array, and then you will use an underscore and the next line and kind of like progressing that underscore. I kind of used that when I was doing the calculator problem, and I'll like progress the underscore as I move the index, and I'll like have another line if I have a new call stack. I think like I kind of use that technique and to explain my example. I think that really made it a lot easier because typically I think like I just wouldn't know like if like I would probably use a different technique that wouldn't be as efficient or clear. But I think like when I saw you did that during like our session, I used the same technique to do the walkthrough, and that was really useful.
Perfect. Yes, so things are already even now, like even though we've been working for like a week and a half, things are already starting to show progress. That's perfect. Even other people are recognizing it. I'm happy with that.
Okay.
All right. With that, let's actually look at your replay. Okay, let me share my screen with you.
Okay.
So I'm gonna look out for like mostly. So this 45 minutes. Did you do any self-evaluation after this?
No, I the self-evaluation is done in the I just wrote like notes in the diary, but this 45 minutes is like me going through the entire program. I think like somewhere in the midpoint it just starts getting a little stagnant because I would just be walking through my example and like the way I did it, and the way I did it wasn't very efficient too, so it just took a very long time to flesh out.
Okay, let me run through this, and then I want you to copy paste whatever you had in your diary, or I don't know if you linked it in the doc, but I'll look at that after.
Okay.
So yeah, okay, I don't see it in doc, so if you could link me the diary and the doc, that'd be good. So let's see here.
Okay. So the problem is compute the spiral ordering of a 2D array. Array is gonna be n by n.
I'm gonna speed it up.
Yeah. Okay. So was given.
I was trying to upgrade to YouTube, but it was too long.
It's fine. Don't worry about it. I can always manage this.
Okay.
Okay. So I'm seeing here.
Based on what I'm seeing here, it doesn't seem like there's a sort of mathematical pattern that we can use to kind of compute the elements for the spiral ordering. Let's see. So after brute forces, we actually traverse the array in a spiral order.
Okay, but that's tautological. That's what I'm asking you to do.
Resulting array. Let's see. As of now, I'm not really seeing any other ways to go by this. Let's see. If we were to do that, okay, let's use the first one for simplicity. Now.
Okay, you're starting with a smaller example. Okay. I think this pit. Okay.
9 to 8. Yeah, 9 to 8, and then go.
Okay. I think this is a little bit strange, but it's fine so far.
Okay, kind of strange in the sense that I picked a smaller one.
No, the strange is that you're kind of repeating what the example is showing. I think I would have. It's like you're kind of doing repeated work here. It's like you already have the example up here, and then you're doing this.
Yeah, kind of repeat the same pattern.
Okay. Wait, hang on.
I was showing the kind of like the n-1. So if you see, I did 1 to 2, and I will separate 1 to 2 from 3 to 6, and then 9 to 8, 7 to 4. But the example was like the resulting array. That was what I was hoping to show.
I see.
Like it's yeah.
Okay,
I'm not with the small.
Go ahead.
Sorry. No, I was just saying like I guess with the small array and the way I wrote it out, it wasn't as clear. That was what I was trying to do.
That's fair. Yeah, I just thought it was a little strange, but like I see that you eventually recognize that you need to go right, down, left, up. That's really what I was waiting for. So it's like I would say there's a little bit of wasted effort here in the sense that you didn't have to write this out, but if you felt that it helped you understand the problem better, then that's fine. I'm not gonna nitpick too much on that.
Yeah, it's one because it has more elements, so it might be easier to kind of show the examples because we were able to kind of show this more.
Okay, so you're just walking through it in order for your purposes.
So first we start from
Yeah, it's because I was just trying to take it really slow. Like you said, I didn't want to rush it, so I was just like taking my sweet time with like the examples.
That's fine.
We go all the way to from 1 to 3. We go all the way to row 0, column 2.
Okay, I'm gonna skip ahead a little bit because I assume that this is what you're just gonna keep walking through this.
Yeah.
Okay, fine.
That's fine.
You're looking for some kind of like pattern that you recognize. Okay.
And -1
Yeah.
all the way.
So I was like, I wrote the actual
minus
coordinates, and
1,
I wrote the more
okay.
generic one with relation to n.
Uh-huh.
To n. So
I see. Okay, so I'm just gonna assume that you are gonna keep doing this
and
as
then
well. I think you start doing this around 3 minutes. Let's see how long this takes you to do.
2, 3, 1, 2, 3.
It's still pretty long.
Yeah.
like,
How long does it?
it's like-
Let's see. Okay. So it seems like you take 3 minutes to do that, actually. So let's see. Let's see what happens.
So at least what I'm seeing is that so we're doing this and that, and then we do.
I think I was like, I feel like I wasted a lot of time expressing the same idea
Mm-hmm.
in different ways.
Yeah.
That was one big thing I realized in the end when I rewatched it, because I felt I could have summarized it a lot quicker.
Mm-hmm. You could have literally just done
get
this.
the point.
You didn't. You already said. You already addressed the spiral ordering. You already said this. So personally, for me, I would have just immediately gone with this because it's not clear. I mean, this because you already said you're going right, down, left, up, and then you're going to go inside one layer in. That's already an idea. You don't need to do all this shit because, like, I know that last time you're hung up on the last problem we did, which was the not compute spiral ordering. It was
2D array.
rotate 2D array. Yeah,
Yeah.
The reason why you're basically taking that solution and copying it here, that's not what I was trying to get you to do. What I was trying to get you to do was really say, hey, run through the idea and test your naive solution. And the fact of the matter is that the spiral ordering that you have here is already a naive solution that works. I think, like, there's no reason to do, like, a four-way swap on this. There's no reason to look at the coordinates just yet. Like, you already have an idea that works, I think, pretty well. Like, the only reason we went to the coordinates on that problem was because because there wasn't a clear solution. Remember, like, going back, let me open the sheet again, just so I can illustrate this. Like, when we were doing the rotated 2D array, we were doing, like, some weird, like, you're getting hung up on these swaps, right?
Yeah. Yeah.
And the reason why we ended up doing like four-way trades was because we realized that there was some inefficiency, that, you know, we were basically, you know, holding things in extra arrays and it was hard to manage, and so we realized that wasn't an answer. And so that's why we decided to go even deeper into the coordinates, because our immediate idea didn't work. In this particular scenario, your immediate idea does work, and I would argue is probably pretty reasonable, you know? I don't think there's like a way for us to get any faster than this. Like, let's assume that you're going to iterate in n time, and the only thing that would probably change is like the memory. So which means that you're not going to know unless you actually start like pushing that code forward. So doing this was wasted effort because, again, you have an idea that works. Why not just drive that idea?
So my question is this. So I have the idea, and obviously I need to walk that naive solution through, right? But I wasn't clear how I would walk that through in terms of like, especially the coordinates with relation to n. So I could walk it through just by without writing like any pseudo. I could just go like, okay, 1, 2, 3, and I'll do 4, 8, 12, 6, 15, 14, and I could show that. But I'm not sure how I could then move forward from that, because like I could walk it through, but then because I don't know how I would express that idea in terms of coordinates, I decided to write it down, if that makes sense. Cause like I knew I had to walk it through, but simply walking it through, I still didn't have enough like information. Like I still didn't see that pattern in terms of the coordinates, like how it would increase or decrease. I think that's where I was really stuck on this problem. Like I think like the idea is definitely there, but like expressing it was the harder part, if that.
It's like, to me, I think you're focusing on the wrong things. I think you're still hung up on like what we did, and you're still paying attention to like, oh yeah, I need to do the coordinates. The coordinates is just a tool. Like, keep in mind, like, when I look at this, and if you described it, all it really is can you iterate through a 2D array?
Yeah.
Yeah, you can iterate through a 2D array. You know how to write that. So you can iterate it, and that's all you're really doing. You're just iterating through it from left to right, from top to down, from right to left, and then from bottom to up. As long as you can write that, you already know how to write the solution, I would argue. Like, there was no reason to dive into the coordinates just yet, because fundamentally, like you already, like you said, you described the solution. Iterate from left to right. can you write a loop that iterates left to right on a 2D array?
I can. That I could do that, but it's like I don't know how to like do like the state management for like spiraling from outside to inside.
Okay.
And that's where I was trying to get a sense of.
Mm-hmm.
Like writing the first outer loop is fine, but then like after that I would kind of need to update the coordinates and like especially with the loops. In this case, like it would be very easy to make some off by one error or like off by one mistake, and that's where like I was really trying to like look at because I knew like that's probably where I would fuck up eventually.
Okay, I see. It's more like you being paranoid. It's you like trying to fight this paranoia. Okay, so let me try to clear this up a little bit more. I know this paranoia is pretty natural, but eventually you do enough of these problems, and then you start realizing there's a rhythm to it, and that you can kind of there's some stuff you can skip. So like for instance, once I compute this spiral order of this, right? Let's say I computed it. And I go into inside. How much do my bounds shrink?
How much what?
How much do my bounds shrink? Like, I have an n by n matrix, right?
Yeah.
What's the size of my new matrix?
N minus 1.
Are you sure?
No. So it goes from 4 by 4 to 2 by 2. It would shrink. At least from this sample, it shrinks by half. But in the last one, it went from 3 to 1.
Mm-hmm. So it's not half. It must be.
Yeah, like log n.
Really?
Isn't let's.
I take out 2 rows.
Yeah. 2 rows and so we minus 2. Okay, okay. We take out 2 rows and we take out 2 columns. So so it will be n minus 2.
Yeah.
Each time.
You see how easy that was? It was just logical. It's like, hey, I don't need to look at these rows or these columns anymore. Those are 2 columns I don't have to look at. Therefore, the next array I look at must be n minus 2. I don't know where this log comes from. I don't know where this weird shit comes from.
Okay, I think if I was able to arrive at this n minus 2, I probably wouldn't have done that many. But I guess like I was so paranoid of like making that off by one error and like updating the state and stuff. I was like, I kind of failed to step back and look at it in a simpler way. Mm-hmm. But that's pretty much how I ended up spending 45 minutes on this problem because that's where I pretty much got hung up on.
Okay, so you got paranoid about the details. Again, the whole thing, the whole theme of this is to set ourselves up so that way the details fill in themselves. If we understand the idea well enough and we understand the parameters of that idea, then the details will come and we can fix any details at the time. And what you've done is actually invert that process. You've decided, oh, what do these details look like? Well, you haven't even fleshed out exactly what you're doing. You know? Like to me, it's like, I don't know why you're it's like if I asked you to design a car and then you started wondering what the size of the pedal was going to be. Does that make sense?
Yeah.
We have all this other structure to deal with.
Okay. I just felt like at that moment, it just felt like that would be the one thing that is like hindering me, and so I really wanted to knock it out. But yeah, I get what you mean.
Yeah, you're worried about the details too early. It's like these details might not even be relevant. We don't even know if our idea is like super optimal. I mean, look at it now, it is, but it's like, it's why didn't we just consider exactly step by step? And I think you're jumping steps here, so I'm gonna say, don't jump steps. Consider step by step, right? So, like I said, you saw how easily I was able to step through that logic. All I did was like take your idea and then do a +1 on it. Like, all I did is like, hey, what? Okay, well, now I need to shrink my array. What is the size of the array? And what indices do I start at for my new traversal? It's a very logical question. It's a very logical follow-up. Okay. So let's see like how what steps you took here. Okay, first traversal starts at C0. Yeah.
Static.
Yeah, you got really okay. I see.
Actually, what do I mean?
Yeah, you're repeating details here. Repeating details here. Repeating details here.
2, but I'm gonna add 1 here so that we actually reach it as well.
Okay,
so we
fine.
can inclusive of the end.
Yeah, so basically you burn. I would say argue that it's probably about 7 to 10 minutes of wasted effort here. Because like, yeah, column is static. Fine. Yeah, second traversal, column is static. Okay.
Yeah, I like when I went to look back at the video, I realized like pretty much like the first part I already like went through the example in the same way 3 times, and then when I did this part, I thought I did it twice, like the part above and the part at the bottom. So yeah, I feel like there was a lot of redundant efforts here.
I think this is weird the way you'd express this. N minus 2 and then n plus 1. This is a consequence of you being overly obsessed with that detail. It's like, this looks so fucking weird. Doesn't it look weird to you?
Yeah, no, it is, but at that point it was like kind of too late to pull out, and I was just like, I'm just gonna commit to what I had.
What do you mean too late? You're only 15 minutes in. You can just, it's just one little thing that you can change.
But I wasn't sure, like, because changing that would mean like changing like the other traversals too, because that's kind of how I wrote them out.
Okay. But you're reassigning end, so I don't get it. What is the issue?
So yeah, later you would see that I end up having like a lot of variables, and I don't actually reassign. They're actually going to be different variables.
Let's see this one,
which is where it gets like pretty messy, because I had like a lot of stuff going on.
Okay. Let's see.
Yeah, the one. Let's see. Oh, yeah, n minus 1 as well. Result.
The odds are different.
As you being okay.
After each time over here, we can kind of do what we have up here: row and column. So row, column plus 1, and the n would.
Okay, this is something I feel weird about. I get that you're doing R and C. Personally, like you're carrying over this variable, and that's kind of like, I think, is causing you some grief. But let's see what you do with it.
And for the last one, row plus 1, column minus 1, and plus 1.
Okay, you're doing, I get it. Your R and C's run out of bounds. You're readjusting it. Why not just call it R1, R2, R3, R4? Save yourself some grief.
Yeah, that's what I did. Eventually, like if you continue the video, that's what I end up doing. Because I realized like there's no way I can use the same RC for all 4 of them.
Yeah, like that should have been very obvious. And not only that, you're already reassigning RC, so like I don't understand where this is coming from either.
No, actually, like at this point, I wasn't really like. I guess it was like pretty close to code, but I wasn't like, okay, this is like I'm gonna write the code now.
Okay, I see. You're just kind of slapping things together and adjusting, but it's like, let me watch a little bit more before I give you my thoughts.
Okay, yeah, sure.
I'm sure there's a way to 4 different functions. Keep repeating them. So let's see, what about we? Okay, so initially, let's see, I have to learn how to manage. Okay, sorry, and for the end of it. So E1 is actually going to start at n minus 2. That's 1. E1. Let's see. Okay, I also mentioned that. Okay, so now if we check if result is length of n minus n, we simply break, and in the end we get the result. So
okay, wait, what is this F1? F2, F3?
Basically for the different traversals. Yeah.
Okay, I'm actually okay with this. Go ahead.
Okay. Okay, and then I was you would see it, but yeah, we can continue.
I just tell me to like we'll just watch the rest of the video if you need me to. Okay, that's fine. I mean, I have no problem with you separating things out in this.
Yeah. So yeah, and then if you fast forward, you will see that I realized I was pretty much like I only needed to traverse like the array in 4 different functions. So I tried to make it in one function, but then that also kind of came back to bite me because I would need to pass in like certain flags to traverse, like say vertically or horizontally. So I think like that was that one mistake I made was like I think like initially having 4 functions was easier because I could just separate them out and it would be a lot easier to manage. But then when I decided, like, oh, what if I could just generalize this to make it cleaner before I actually flesh out the 4 different functions? And then when I tried to generalize it, I realized like, okay, shit, now I have to pass in different flags to know like what type of like traversal I'm doing, and that kind of came back to bit me.
Yeah, so this is like going back to the whole issue of you being overly pedantic about the details before you even know what you're writing. You see here, like you're managing all these different variables. To me,
Yeah.
like this could all be like if I had to redo it, I would just literally think, okay, all I need is like a top bound, bottom bound, left bound, right bound. That's it. And then just like shrink it each time I complete this loop. Shrink those bounds. And then like when I go into those F1, F2, F3, F4s, right? Then I just do something like top bound to, like if I'm going down, I go from top bound to bottom bound -1 or some shit, right?
Yeah. Yeah.
That's all I would do. Like when I'm looking at this is just you as a consequence of you being overly pedantic about these details. So let's walk through the chain of thinking that you've done here. And I'll show you how this all comes together. So first things first is that you're overly pedantic about the coordinates, which leads you to being overly pedantic about the coordinates when you do the traversals, which leads you to managing all these different variables and then doing these weird adjustments, which doesn't even really matter, right? Because integers are passed as copies into the function call stack. So like this, like I get these are all separate functions, but then like you don't need RC if you're going to make these different functions. And then which leads you to managing individual what's it called? Individual variables for each one of these individual functions. You see how like we're built because you literally just keep focusing on these details without like considering things from the top down. You end up with this very messy code. Now, granted, it probably works. It probably works, but it's just like it just looks so shit that I would not pass you anyway.
Yeah.
Like let's go from the opposite direction, like from the top down, right? Let's say that we went through the whole thing of like spiral order. And then let's say that we go from left, right, bottom, top, down, and we shrink the array, right? So then all I need to do is like, okay, well, what's the size of my array? Okay, it's gonna be n-2. Okay, so then what are the indices of iteration from 0 to n, right? And then let's say I complete that traversal, right? I go into the next array. What is the indices of traversal? It's gonna be 1 to n-1 or n-2, right? Like whatever. Yeah. And then you just like kind of repeat that, and you see, oh well, each time my indices just shrink from this to this, and then I would just think, okay, well, my bounds are just gonna be the ones that change in this array. So then that's how it leads to my top bound, bottom bound, left bound, right bound. But you see how each one of these steps and ideas are logically following from one another.
Yeah, I definitely missed that question you asked about like, oh, how, like, what is the change in the size of my array in each iteration? I didn't really ask that question. I was more hung up on like the details, like you said. I was asking the question like, oh, what are my indices? Like my indices are going to be changing. Like instead of asking like the array as a whole, I was more focused on like what are my indices going to change for each of these traversal. I think that's where I kind of screwed up. That was my first logical question instead of how is my array changing.
Yeah, so that's just something I want you to take away at least from today. Don't get hung up on the details too early. You get hung up on the details too early, you end up with shit like this. That's really the big takeaway here. So then let's keep going through the replay.
But yeah, like I said, like halfway through at this point, the rest of the video is just me like fleshing this entire thing out, which took like a long time because there was a lot of stuff to manage. Repeating them.
And that's all this is just a consequence of you getting hit with like starting with the details and then like doing all this shit. So, so I would say like even if you had to manage the details individually, I would have just considered these each individual functions and each individual variables and then treat these things one by one. But then that means that you have to isolate your testing as well. And so you running through all this is just like, again, you're not seeing the forest for the trees or whatever the saying is. Again, like you're being thorough. I appreciate that. And you realize, I only need, I guess it's you refactoring it, right?
Yeah.
Okay. Yeah, I don't think I need to see the rest of the video. I think I pretty much described what the problem is. My question to you is like, when you're watching this, what are the things that you picked out? Actually, I want to see your practice diary. And then you like you testing at the end is just because like this entire thing was just so complicated and so weird that you weren't sure of yourself. That's it. So let me actually see your practice diary. So let's see what you wrote.
I actually didn't pick it up. I wrote it right before I watched the video, but then after watching it, I realized like the stuff you just mentioned. I didn't really. So yeah, I didn't pick up that I was hung up on the details. I wasn't able to get to that idea, that conclusion. This is right after right after doing it, and then after watching the video, I didn't write it, but then I realized I was doing a lot of redundant stuff, and that wasted a lot of time. And the second thing I picked up was I'm trying to think. Sorry.
It's okay. Take your time.
I didn't ask the right logical question. I didn't go the right path. If you get like from a logical sense, I feel like I didn't really take the correct path. Like you started at asking, okay, I have this idea. Then your next question was like you run it through the example, and then your next question was like asking like what the array would change in terms of size. But I didn't have that step. I felt like I was going through some sort of like logical sequence, but that sequence definitely was not ideal. But I was not able to kind of deduct like what is the right path, if that makes sense.
Yeah, I think that's just a consequence of you not watching your own replay. I think that's just you doing like the gut reaction, but not really sure what.
Yeah.
It's like you're focusing on too much on the details. There's almost always like 80%, like I would say like at your level, 80 to 90% of the issues always stem from something you did earlier before the problem even shows up. Before like the oh yeah, why am I so slow? Well, chances are you fucked up something like way before. I want you to do, I think these replay analysis, go ahead.
Can you elaborate a little more on that? I actually want to know more what you mean by like me fucking up something before the problem.
Yeah. So let's go. So in this particular problem, you basically started focusing too much on the details, right? And I showed you how focusing on the details affected your functions that you wrote, which affected the end of code that you wrote, which affected how you tested. You saw like how that grew from that one idea, that one wrong turn you made, right? And let's also take this one as well. The one where you have the what's it called, the problem we did last week.
These are the new code because I have to do it as homework. The previous notes were below it.
Which one? This one? Oh yeah, I did the homework. Okay, I can grade. Yeah. I can look at your homework actually. But I would say that this is almost a similar symptom where it's like you basically gave up on it and you tried doing random shit, but it's like because you didn't do a logical check of like, oh, what if I do a four-way swap? You tried doing random shit. And because you tried doing random shit, you weren't able to understand the problem. And because you weren't able to understand the problem, you just ended up doing like, again, like your code just kind of went nowhere. And you weren't able to solve the problem. If you just like literally did not try random stuff and just logically followed the chain of problem solving, you would have been able to solve the problem. So let's actually look at your write-up here. Let me actually fully read what you wrote for the diary first before I go to this. Approach was in the right direction, but extremely slow in details, blah, blah, blah. Didn't have an idea in terms of how to do it elegantly, so went through the rough approach, which took extra long to implement. Yeah, this is like semi-true. EPI breaks down the answer in a generic way and makes it as generic as possible, starting with a sub-generic idea algo. I should have spent more time on generalizing my answers instead of giving up so quickly. I would say this is the wrong analysis. Again, I think what I would want you to do is like for future some problems, maybe one other problem this weekend, try to record yourself. It doesn't have to be in time for our like Saturday check-in. It can be like sometime later, but I want you to do it one time, and then watch it yourself, like what we did here, and because I think that will change your perspective on like what you need to evaluate.
Okay. I do want to say, do you mind going through the homework actually?
Yeah.
I actually saved the homework for last because I knew the spiral ordering was something like it would help me with finishing the homework with the rotating 2D array. And I felt a lot better when I actually came to this 2D array with the write-up. I kind of summarized what I did. Because we already did it during our coaching session. I knew what it is not to try. And with the spiral order 2D problem, I knew I wasted a lot of logic on stuff, on like a lot of details. So and when I went to this homework, I knew like, okay, n-1 is definitely the way to go. And this, when I retried doing this homework problem, I actually felt like it went a lot smoother than the first time, especially after doing the spiral problem too.
Okay. Let's actually see what your write up looks like. Sorry, 1 at 32 minutes. Okay, sure. I think that's cool for like the first time. Okay, well, second time.
Yeah.
I would say if this was the second time doing it, I would say try to do it in like 25 minutes. So I'd be looking to
Okay.
save 7 minutes somewhere.
Yeah.
So this probably would have been a good candidate later on to do a recording of, but okay, whatever. Because first time, because it's Spiral 2D, okay, intuition n-1. Swap the n-1 from the first row. Yeah, so you understood that. It's surprised it worked. Tried it on the 3x3 array and worked at this point like 15-18 minutes. My question is, why did it take you 15-18 minutes to realize this when you had that intuition? I would have expected it to take like 10.
I had the arrays like copied out, and I was like trying it one by one at the top. That's why I ended up like the document.
Wait, where did you start the problem? Let me ask.
Yeah, like
here.
Like here, like at the bottom, like the 13951 as well as the 741. I basically like had the original array, and then I would try that idea out. Yeah, and then the write up was done after I finished the entire problem.
Okay.
But that's where I started at.
Okay, so at what point were you at like 15 minutes? Here.
Yeah. I think maybe below that.
This?
Can you just go? Let me actually go to the doc.
Yeah.
15 to 18. No, actually, I think at 15 to 18, I was like over here. So
Okay.
I was starting to write this this out.
Yeah, I think that okay, so like when I see this, I'm thinking that you are overly paranoid about something. Were you like checking the n-1 swap over and over and over again?
I was checking my idea of I was checking the swap and the reverse after. So I tried it at the 4x4 and I tried it at the 3x3 because I was still paranoid, like you said. But it wasn't as bad as the spiral one. Because I don't have to keep track of a lot of the indexes and stuff. At least I don't have to keep track as many indexes as the other one. So I was less paranoid with this, and also because it was my second time trying.
Okay. Let me write down like you're overly paranoid. This is something for me to fix for you.
Okay.
Okay, it's fine. Overly paranoid about testing idea. Okay. It's like. Okay, we'll work on that later, but for now, I think this is okay. I'd rather you be thorough and paranoid than to be careless. So it's like, okay, fine. So start with the row, swap n-1. Yep, that's fine. I'm okay with this. So then let's see what else to write. Start writing pseudocode, which might flesh out some detail. So then it took you like 13 minutes. Let's just say like 13 to 15 minutes to write it. Fine. 13 minutes to run it, test it, whatever. Oh, okay. 3x3 against pseudocode, proceed to actually code it out. So say 4, not as elegant as API, and they have different 4-way swap. So the first try. Perfect, good. I'm happy about this one. I mean, definitely it's like a second try, but like, if you could do it first try, this is like our goal state.
Yeah.
So if you can do this, and every single problem, like even if you're overly paranoid, even if it takes you like double the amount of time, I would be happy. Because after that, all that's left is just for us to take out some unnecessary steps. But I'd rather you have all the steps in there to begin with. So
I wrote the code right above this write up, and then I submitted it on LeetCode, and then like I'm glad I actually worked the first try.
Mm-hmm. Yeah, that's the golden scenario, and you got there. Which is really good. I mean, again, it's the second time you tried it, but it's fine. So then you testing this, it's fine, and n squared for swapping.
N would be like not the entire array elements, but it's like n by n. That's why it's n squared.
Okay, I see. N is not okay. Okay, that's fair. I'm okay with this. Yeah, let me double check. So n-1 exclusive. Sure. Swap n. Yep. Yeah. Okay. Swap one at a time. Yeah. Okay. Yeah. The API does like a 4-way swap. and you just swap one at a time. Okay, I'm okay with that.
Yeah.
Yeah, and then like I would also try adding on like what did you have to know or think of to get to the EPI solution. I think this is something that I would want you to write as well.
Okay.
Like what was the insight to go from your solution to theirs? You know, like what would have been that extra step to push it over the edge? Because you get like a lot of brownie points from these interviewers if you can come up with not just the solution, but a solution that works super elegantly and super well.
Yeah.
So we're aiming for perfection here. So this is good. But other than that, I'm looking at this. So the only thing that's left is being overly paranoid about testing your idea. Okay. So if I had to tell you to focus on something, yeah, keep getting your ideas out. I want you to still focus on this one idea that we talked about last time of driving the idea first. Keep going with the naive solution. I really want you to focus on that.
Yeah.
But let's add one more thing. I want you to actually just go from top down logically. Just follow the logic.
Okay.
Follow and trust the logic. Just do this one thing. Like if you can do things from top down.
Okay.
I think this might fix a portion of it. I'm not gonna. There's more things I want to tell you and show you, but I feel like it's gonna overwhelm you. I want you to still focus on this idea of driving with the naive solution because it seems to be working. But just go from top down.
Yeah. I just feel like I'm like going pretty slow, but I wasn't trying to like rush it because when I rush it, I tend to make mistakes.
Mm-hmm. That's fine. What I want we're getting you to a point where you can spill out the naive solution and test like Naive's ideas and then test it. But again, the problem I'm seeing right now at least is that you are taking a long time because you're starting on like you might have the idea, but then you start like going from somewhere else, like somewhere down later on down the problem with the details, and then going going from bottom up. And so what I want you to do is like drive that idea and stick with that idea by going, what's the next logical step? What are the things that can go wrong in this step? And then just grow the idea instead.
Okay. Yeah.
Okay.
I definitely realized this when I was doing other practice problems as well. The logical path I was following was not like good enough.
Yeah. Let me see your other practice diary. Okay, so greedy, string of curtain. Basic. Okay, mock. I'm actually curious. Analyze problem, useful examples, tested through. Flesh out pseudocode, proceed with pseudocode, fine. Then wrote code, feedback coworker, asked a lot of clarified questions, did a walkthrough, but there was 1 or 2 points that could have been elaborated, clarified more. Should have talked about the complexity a lot more as well. Okay, that could have been clarified more. I would say that's probably due to how do I describe it? Based on what I saw today, I think it's you being overly focused on some of the things that don't matter and then not focused on the things that do matter. I think that's probably what I would guess he kind of said.
Okay.
Does that sound about right?
I did spend a lot of time talking, but I ended up not talking about something that I should have talked about. Like I did run through like the examples a lot from software, but for example, computing the digit was another thing that I was like, okay, we can come back to this later, and I felt I could have at least told him like, oh, I would compute the digit by getting the current one and then multiply it by 10, takes the next one and stuff like that. But I feel like that's something that's pretty vital to the solution, but I didn't elaborate on that because I was like walking through the entire example.
Okay, so I'm gonna add this. Focus on the things that solve the core problem, because what the sense I'm getting is that you're talking about going through the stack and the little details. That shit should be automatic by the time you look at a problem. You should immediately be able to do this like mentally in your head, like tuck 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 tuck. That's what I mean by autonomous proficiency. All that's left at game day is really to make sure that you do the problem solving step by step. So if you're talking about like how a stack works, that's not good. And I don't think you should be focused on those details. You should be focused on solving the actual problem and then using code in order to solve that problem, not the other way around. And so I'm going to say focus on things that solve the core problem. And the good thing about doing things from the top down is that the more closer they are to the original idea and problem to begin with, the more likely they are to be important to solving the actual problem itself. So this kind of takes care of itself. It's 2 birds with 1 stone. So just try to pepper that in if you can. If you can't, then we can focus on it next week. But yeah, just try to drive that idea along with like writing out your naive solutions. So, okay. So let's see. Buy, sell stock once. Have done this a couple times. So you have an idea. Didn't remember a solution that was that short. Tested on a couple cases. Get a working solution sooner than I thought. Yep. Yeah. As long as you did it first time, 12 minutes. Pretty good. Buy and sell stock twice. Okay, this took at you an hour and 15 minutes. Vague sense,
I
but
was
stock.
not really able to
Mhm.
to solve this.
Okay. Should have looked for other ways of parsing. I would be a little bit more, especially if you haven't solved it didn't solve the problem. I'd be a little bit more detailed than this. It's like you should have considered other ways of parsing, like the logic. Like, what did they consider? What did you not consider? And how would that have led you to the answer? You know. And then the next step after that, what did they consider? What did they not consider? And so on and so forth. To be a little bit more detailed. This is this is too vague.
Okay. But yeah, to give you more context, the thing I was missing was like the one thing that they did that I didn't was that they also considered like parsing it from backwards, and that's what I like entirely like didn't think of. Like I was just thinking about like moving it from left to right, and I completely missed out on the backward traversal and how that would, what kind of results that would have gave me, and how if that would help the solution.
Okay, my question to you then is, why did they think about traversing it backwards? What led them to it? And could you derive it?
Okay, I guess I didn't really ask that question and answer that question because I was really not sure how they derived it.
Then you need to go back and redo it. You need to redo and look at that problem again. Because the question we want to answer when we can't solve these problems is, what was the insight it takes to go from our solution or our state to theirs? So let me write that down. Go from our state to theirs. What was the insight they used to think of the idea? You know, because like this idea of traversing backwards doesn't come from nowhere necessarily. There's a reason why they thought that, and I need you to get that reason.
Okay, like they explained it was because it's efficient that we keep computing from left to right. But you know, I definitely knew that was inefficient. Like when I was doing it, I had the same idea as them that okay, we both know that this is inefficient, but then they were able to come up that okay, what if we also did it from the other way as well?
Right, but there are no magic bullets in these solutions. There's a reason why they were thinking it from backwards, from right to left. What was that insight? What was the thing that they thought of? And that's what I want you to find out.
Okay.
And then from there on, trace the logic. I really want you to focus on the tracing the logic.
Okay.
Okay, and then other than that, so you did like 4 or 5 problems. Fine. Delete duplicates in a sorted array. You did that. Okay, actually, you did more than that. 8:30. So I assume that you did some problems after our coaching session then. Because I see some for October 26th.
Isn't 26th on?
Oh yeah, Tuesday. Yeah. No.
Yeah.
Okay.
Yeah, I did do some problems, but it was in like S0. I was just kind of looking through like my past, revisiting my past problems. So I started writing diaries on 26th.
Okay, the ones that take like an hour 45 I'm like might need a second look at that. So, cheapest flights, case stops.
Yeah.
Okay, this one you should have next 20 minutes to try to optimize it. But you passed 27 out of 49 case on leak code. I would definitely try to say. Go ahead.
Yeah. So this one, I like initially I was like pretty happy. I was like, oh wow, like I first try I felt like this idea really worked out. But then I realized like okay, when I submitted it, it wasn't fast enough. So I felt like that was like kind of like a punch to the face because I was like, oh, this it seems like okay. I did the inspection, everything was fine. Complexity wise, like asymptotically, it's fine. But then when I submitted it, it's like not fast enough, and there were like certain optimizations I didn't do. But I'm still looking at that one because they also have like other solutions. So I'm still looking at that one.
Don't worry about that. Right now we just want to get you to the first step. We'll do the optimizations later. But we want to get you to a point where you can come up with like, for like 80% of the solutions, you can come up with the optimal solution pretty easily. We'll deal with this one later. Because you could get to like a solution that works in 20 minutes, and then you spend 20 minutes optimizing. It's like, okay, you tried it. We haven't talked too much about that, but we'll deal with it later.
Yeah.
Don't worry about it.
Okay.
Delete duplicates from an array. That looks pretty easy. I don't care.
I think the advancing through an array one was an interesting one. So I didn't write it down here, but but I started with the brute force like I mentioned. I actually coded out the brute force and I optimized it to use memorization, and I actually ended up with the bottom up solution. And I thought like, okay, bottom up is typically like the most optimal, and I guess that's where I was wrong. Because they were actually able to do it like an O of n instead of like n squared, but because I kind of like went in with the mindset that said that, oh, this is a DP problem. If I could get the bottom up, then I should be good. But turns out I was like wrong. On this.
Go ahead.
No, that's basically the main thing. Like I was glad that I was able to start from brute force and like made it all the way to bottom up, but then I didn't try to like optimize it even further at that point. Like I got to DP, like bottom up DP, and I was like, okay, I think this should be good. But I felt like that was like me being careless.
No, so basically this just involves like, okay, now I have an idea, I have a runtime for it, can I get this faster? That's really it. It's like you committed to it without thinking about whether or not you could get it faster. That's it.
Okay.
So it's like you said, you walked in with this expectation that's going to be a dynamic programming problem. And that is also what killed you at the end. Like I said, there's almost always something at the very beginning that kills you at the end. It's never just like, oh, I just didn't have to make this one step. There's always something at the very beginning. And this is the one thing. You got hung up on dynamic programming and you said, oh, this must absolutely be the answer. When, give it a chance, It was an n squared solution, Maybe you can get something easier and faster. I mean, points for getting dynamic programming, but, it doesn't matter if it's like faster.
Yeah, okay.
So I'm gonna say don't be too married to the initial idea. I think that's probably the lesson there. Don't be too married there. Struggle to set up with one. End up with a solution that's the same asymptotic complexity, but 2 passes instead of 1 optimal pass. Sure. Classify array into 4 buckets. Okay, 3 points. So the question is the same thing. The Dutch national flag problem. What was the insight you needed in order to try and figure out how to get to their solution? What was the insight?
At that point, on that day, like after doing it and then looking at comparing the solutions, I feel like I just didn't press on the idea more. Like you know how you mentioned like follow back to notes, follow from top down, go logically. So I feel like I didn't go as far as I could have. I got to a step and I was kind of stuck, but I feel like I also wasn't asking enough questions for me to break through that point.
Okay. I mean, I get it.
Yeah, and sometimes I just straight up like like I know I need to ask questions. Like I need to ask what's the next logical question, but sometimes I can't find or see what's the next thing to ask, if that makes sense.
Okay, it's like something you can't see what makes the next logical step. I think that's what you're saying, right?
Yeah.
Okay.
Like, what do you do in that situation? Do you like step back and like?
Usually I just ask myself what I need to know and then how do I get there. That's the whole debugging thing. Like, okay, what's preventing me from knowing what I need to know, and then just like kind of trace that back in my head.
Okay. I'll try to work on that and recall myself a little more so I can look at myself as well.
I think knowing, like, it's one thing to be stuck, and then being able to debug that your own thinking it's a very difficult skill. Don't get me wrong, and it takes a lot of practice to like really understand like what you need to know, why you need to know it, and what's stopping you. But overall, I think that I would say if you run that situation, I think that usually it means that there's something that you've assumed that's correct that is incorrect, and that's kind of like where paranoia kind of helps because it allows you to break down your own preconceived notions. But then, it's not efficient, but it definitely will get you to the answer. If given an unlimited amount of time. But don't worry about that too much. You get stuck. then chances are that you just didn't have the right tool, you didn't apply the right tool. Because again, this space, this fucking doing interview problems, it's deterministic. Like the answer is known. It's just, and almost for every single problem, there is a deterministic way of getting about the answer. We're not, fortunately, we're not dealing with something non-deterministic like saying like play Dota or whatever, you know. So it's like this is a lot easier. So don't worry too much about that. Focus on solving the problem, and then when you go watch the replay, think about what you could do better.
Okay. Okay.
Yeah. But that's it. For me, we have 5 minutes. Any questions?
Yeah, I actually can't make it this Saturday. Is there any other like times you could make it? So I could do like Saturday like evening, night, or even like Sunday morning as well. But because I'm flying on Saturday morning, I couldn't make it.
Okay, so you can't do Saturday morning. So you're saying you can do Saturday evening?
Evening, night, Sunday morning, yeah, those work.
Okay, so let's do Saturday evening. I think I gave you permissions on the calendar that you could reschedule it, right? Did I give you permission? Let me check.
I'm not sure if you did, but I can take a look at it later.
Yeah, let me check. Too busy. RSVP, yes. Calendar modify. Oh, yeah. Let me. I'll give you a permission for this at all events. Okay, so I gave you modified permissions. Go ahead and reschedule it as you need.
Okay.
But and make sure it's just this one. After this week, it'll be fine.
Yeah. This one.
Okay. And then let me go ahead and go to Google Sheets. Let me look at your study plan.
Okay.
Okay, so you're still doing array and recursion, correct?
Yeah.
Great.
So I was mainly doing like the array on ETI, and then I would like randomly jump at LeetCode to pick like some recursion problem to do.
Okay, that's fine. I do see you have vacation next week.
Yeah. I won't be studying as much, but I do still plan to study.
Okay, I would say like if you can, at least try to start reading some of DDIA. I would say
I actually started. I got the book last week. I started reading this past weekend.
Okay.
Yeah, but I'm going pretty slow. I'm going like maybe 10, 15 pages a day.
Really understand these chapters because I think like this book, I can't read more than 10 pages without. I was just like, okay, fuck, I need to stop and then really read those. Like it takes me like 10, 15 pages to read that, even though I've read it before. It's so fucking dense.
Yeah, it is. I'm pretty slow on it.
Yeah, so don't worry about it too much. Just focus on like being able to hammer this out. I think, based on what I saw today, I think you're probably like 2-3 weeks out from being good at the coding interview, LeetCode stuff, and then we can focus a lot heavier on the system design. But yeah, that's basically my evaluation of today.
Okay, sounds good. Appreciate it.
All right. Anything else that you need from me?
No, I think I'm good. I think you typically narrow it down pretty quickly.
All right, sounds good.
In terms of what I need to work on. Yeah.
Okay.
Have a good one.
All right, you too. Take care.
Bye.
Bye. Okay, that was that. And then we will have one more client show up. So if there's anyone in the crowd who has like questions or something, feel free to ask. Have I ever heard... Okay, so Alo asks, how much easier do you think having experience at a mid-tier company will carry you to being able to interview at FANG Unicorns? Honestly, like, if you're just starting out, any experience is good experience. Well, you know, as long as you learn from the right people, like, you put your 2-3 years, you can easily get, like, L3, L4 job at FANG or Unicorns. I think we don't really discriminate on that. But yeah, like, everyone starts from somewhere. Take what you can get, man. And as long as it's a good learning environment. Have I ever heard of Reacto? No. And then Bob says -2. I'm not sure what -2 means, but yeah. Let me bring on my next guest.
Recording in progress.
Okay, let's see what he got. Hey, hello.
Evening, Edbert.
Hey, what's up?
How are you?
Yeah, I'm doing good. Yeah. So, how has your studying been since Tuesday?
It's been pretty good. Just finishing up the DFS problems right now, and did the for the homework the serialized and deserialized one.
Mm-hmm.
Did that today, and yeah,
All right.
yeah. Did you see the new Facebook?
Yeah.
Yeah, it's fucking crazy. Holy shit.
Yeah, they just renamed Facebook to Meta, and you know the funny thing is, like that we actually Meta Materials, like it's completely fucking a completely irrelevant stock, literally just like blew up. Hold up.
Really?
Yeah. Let me actually show you. So literally everyone fat fingered it, and they literally got the wrong freaking stock. So if you type in Meta Materials here, let me share my screen for a sec.
Okay.
Like, look at this. Look at this fucking price action after hours.
Oh my God! Wow.
Everyone's so fucking confused. They fat fingered it.
Yeah.
What the hell?
Yeah.
So, congrats. If people bought this shit today, congrats. You're fucking rich as fuck.
Yeah, man, this is like last year or in January or something like that. Wall Street bets kind of stuff. Fucking crazy.
Yeah, what the hell? What the hell is this?
Oh, interesting.
What happened here? I don't know.
Oh
I don't know with Wall Street bets or what. Like, holy shit. Okay, yeah, I don't know. Markets are dumb, but anyway. Yeah. So let's actually focus on what you. So how has the problem solving felt in the past 2 days? Has it felt better?
I think like the problem solving has been like fine for the most part when it comes to the medium problem. But I think like in terms of the serialized and deserialized one for the homework, because I kind of like just targeted that low key. Like yeah, that one was brutal, man. I'm not gonna lie. Like I was looking through the replay, and I guess when it comes to the hard problems, I was just kind of like, it was hard for me to kind of repeat the same kind of like processes that I was able to do with the medium problems, like, you know, just test with pseudocode. I had to keep going back and editing just kind of based off nature problem. But when it came to the other problems, like I think it was okay, like for the most part. But it was just the serialized and deserialized and array tree one for the homework that I was like, it took like a long time to do essentially, and I only got like half of it.
Okay, I see. And you didn't finish it? When you said.
I did everything I did the serialized one. The deserialized one, I kind of just was like, I thought it was going to be easier, I guess, to do. But no, I didn't do the deserialized one. Yeah.
Okay, so is that your replay?
The replay is the serialized, because I thought we were going over like that one for today for the replay.
Oh, we're going to go over. I was expecting you to get both done, actually.
Oh, okay.
Okay.
Gotcha.
Yeah.
All right. Yeah. So yeah, that's kind of when you asked about problem solving, that was pretty much yeah. I did like 2 of the DFS ones, and then this one was the problem. I feel like that I was doing. Yeah.
Okay, so you only did like 3 problems since we met.
Yeah, pretty much.
Okay, I was expecting a little bit more, but okay.
Okay.
Yeah. Like let me look at your sheet. Let me see. Okay. Yes, it's sleep. You have 4.5 hours, 3 problems. Okay. I assume that you didn't do any problems today.
Yeah, today I was doing the replay mostly.
Okay, that's fine.
Yeah.
Yeah, that's okay.
Yeah.
Yeah. Let me know if if Thursday night ends up being like, oh, you want more practice in between our sessions and replay. Let me know if that needs to be a thing.
For sure, yeah. No, I think that's something worth mentioning just because I was doing the replay kind of analysis and like in terms of like fitting it in and stuff like that. So I wasn't really sure, but I guess but yeah, I'll think about that actually for sure.
Yeah, let me know if you want like more practice. So we have more things to discuss on Thursdays, because we can just shift it to like Friday if need be.
Okay. Totally.
Okay. Anyway, so let me. Do you have a replay available for me?
Yeah, for sure. Here, let me send you the replay by Zoom. And the Google Docs for it is here.
Okay. Yeah. Cool. Let's take a look at the Google Doc. All right. So this is the deserialize. Okay. Cool. Okay. I'm gonna watch. Let's watch a replay. Okay. Let's see.
It's pretty long, like right now. So I've included some of the notes on the bottom. So if you want to go to those,
what I do is I'm gonna look at these and I'm gonna look at your notes a little bit later. But let's see.
Okay.
Let's start with how we want to present. So we have each node and its children. We want to essentially display as such.
Okay, so yeah, you start off here, fine. You kind of knew what you wanted to start off, what your opening move was. I'm fine with that. Let me see here.
Like we essentially just pop node.
Okay, so you decided to go with BFS.
Yeah, so just to kind of give context, like I couldn't, my thought process was like, okay, I know how to do BFS, right? And let me try to see if I can like edit that for this problem. So that's why I'm kind of like drawing it out and stuff like that. So
okay, I mean but then that kind of defeats the purpose of like the string representation, you know? The reason why is because like this means that you already know how you want to represent it. And so all you had to do was like, okay, well, why did you know to represent it like this?
Yeah, I think like I was just kind of lost as to like kind of just where to start. So that's why I kind of went with like a BFS just to see if I can like if something would like just click in my head.
Okay.
Yeah.
That's fine. But yeah, then it kind of, again, it defeats the whole purpose of like coming with like this solution to begin with.
Okay.
That's so to me, I'm just like, it's like you might know what this is, but then it's just like, you know, how do you get there? I'm like, it's like there's no connection between what you're trying and what you proposed here. So this would be like a red flag if I was an interviewer.
Gotcha.
So anyway, let's keep going.
So okay,
so here's the thing, you're kind of going with a pseudocode, but then I'm just like, did you try testing the idea to begin with? Like on just like in general, because like you should you know what a breadth first search looks like, right?
Yeah.
So couldn't you have just like tried to like run through it on the example, just like playing without code?
Yeah, I guess having the code out kind of gave me like a template to work with, so that's kind of why I wrote it down. But you're right, yeah, I know what it would have looked like.
It's like it gives you a template, but then it's like this whole idea that we've been working towards is like we don't want you to start off with the code. We want you to start off with the idea and use the idea to drive the code. And the fact that you do this is like it's very concerning for me.
Okay.
So I don't want you to do this. I don't want you to like write code like this, especially if you already know what it looks like.
Okay.
So I imagine this is gonna bite you.
Like something like this, right? F.
Okay,
I,
fine.
G, H, J. Okay.
Okay, so
And
I
last one
mean.
would just be like, you know,
Okay. Fine.
B, K. So this is what it would look like kind of from like a breadth first search kind of approach, right?
Sure.
However, like if you notice, like it's what's kind of missing right now is we don't want to necessarily be pushing it. It's essentially just not represented in the way we want it to look like. You know, the parent-child relationships aren't displayed properly.
Okay, good. Identifying
so
the shortcoming. Fine.
That would make sense. Well, I like the Q idea just simply because like I mean, it's easier for me to visualize in my head kind of what's going on.
Okay. Just because it's easy for you to visualize in your head what's going on doesn't matter. I mean, in the sense that what takes priority is solving the damn problem. Your comfort is secondary to that.
Right. Okay.
Like we want to solve the problem. We don't want to feel good. Like if I fucking went to the interview and smoked weed for like the entire 45 minutes, I'd fucking feel good. But like I wouldn't be solving the problem, and the interviewer would just be like, "Fuck off," you know.
Sure.
So it's like that. It's just like that. So.
Okay.
Like how can we, for like example, how can we get E and F, like this section right here, be within, like how can we turn this?
But at least you're identifying what you're missing and what you need to do. I'm okay so far.
Slash just B, for example, right? Just. And
But
then
yeah, I think
B
you could have
would be
done this without the code. Fine.
F.
Oh.
And 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 for each one of these length, we will also just be adding it to the queue actually. Like
Okay.
queue, add current nodes children.
So I get you're just trying to figure out. So right now you're just trying to cram
Right,
the
so we have an
BFS
extra here, and
into keeping the
absolutely.
parent-child relationships. To me, that means that you haven't tried. Like, there's one point that I talk about in the practice where it's like you have to try to abuse the pattern as well when you go to practice it. Have you tried that step?
Abuse the pattern?
Like, try to incorrectly apply it. There's like one video I did
Oh,
where
yeah.
I said, hey, yeah, what happens if I try a BFS on a DFS problem? And vice versa.
Oh, so trying to cram it. Oh, okay.
Yeah, it's like making these mistakes ahead of time. And I literally did the exact same thing in this like you're doing right now in that video. And I just realized, hey, wait a minute, if I want to keep like the depth and the child relationships, then I do DFS. That's literally what that's literally all it is. It's like, hey, I could have done this, and fuck, god damn it. Fucking Discord, sorry. God, where's this coming from? I thought I quit all the tabs. Anyway, okay. Anyway, let's keep going. So, it's just like if you had made that mistake before on practice, you wouldn't be trying to experiment with it right now. So I assume this is going to take you like about 10 minutes. Is about right?
10 minutes to realize that it's not BFS.
Yep, that you can't do anything with it.
Let me actually see real fast.
Yeah.
I think it, yeah, actually, yeah. Wow, yeah.
I did that without even looking at the fucking notes.
Yeah.
Oh.
Okay, yeah.
It's fine.
I think so, yeah, yeah. It's around 19, I believe.
Okay. Yeah, so you're going to be just
Alright,
basically
so
trying to
I'll
cram
tell you.
shit here. I'm just going to skip through this. I don't need to see too much of this. Yeah, I mean, ultimately, I'm going to tell you right now, there's no way to do it. There's no way to cram all that shit, cram that relationship into BFS. But again, it's because I assume that you're not comfortable visualizing DFS. That's kind of like what my takeaway here is.
Yeah, I think it kind of going back to like your previous comment when it's like why am I kind of like writing the pseudocode and stuff like that? I think like I just didn't have like a clear idea. Like I couldn't come up with like an idea that like kind of fit in my head to kind of test it out with.
Mm-hmm.
And so that's why it's like I'm kind of editing the pseudocode a lot, which I believe is fine because we're trying to massage it, or at least I'm trying to massage it here. But yeah.
Okay. Yeah, so then let me write that down. Not comfortable with DFS, need to visual in head. Okay. So I think you need to be able to visualize this recursive in your head as well. So it means that, to me, it means that you haven't done enough problems like on DFS where you've actually tried drawing it out before the code. So I think, let me look at your study plan. You're pretty similar to the guy I'm coaching that I had on stream before you. I think you guys might do well talking to each other.
Okay.
Yeah, I had you do depth research last week. And you finished up a little bit of DFS. It means that you didn't practice, it feels like you didn't practice DFS well enough then. So I'm kind of curious like what happened there.
Okay.
So like the fact that you're not visualizing it, it says that there's a red flag in your practice. So I will look at that. Okay, red flag. I'm gonna look at how you do DFS problems later. So I'm making a note to myself on that one. Okay, so then you figured that out.
So we do function call on K.
Okay,
Now
so
we're at
then
the
let me rewind this a little bit.
And we're back at B. Okay. So we're at B.
So
now
is
we're
this the
at
part where you
function
actually
call.
start realizing you need DFS?
Now the function call
Yeah,
goes on now.
this is.
Do we need to do the return part in white?
Okay, I see. So then you realize, yeah, you need to do DFS. But for me, it's like I don't. I mean, you're kind of building out as you go. I would rather you run through the problem first. You know, run through the problem,
So yeah, that was kind of like a question I had, like, and correct me if I'm wrong, but like for this problem, it was really hard for me to just come up with um, like it was hard for me to come up with a solution without kind of like iteratively like adding to it as I went along with the testing. Like essentially how I was able to come up with a solution was like just by the testing, like kind of saying like, oh, this doesn't look right, and then go back and fixing it there. Um,
I mean,
I don't know if that's like recommended. I don't think it is, but yeah.
I would try to get it right the first time, but like sometimes there are problems that you there's no there's like you kind of need to do that iterative process. Sometimes that's unavoidable. But to me, this problem is like, okay, well, I know I need to do a DFS because I need to maintain the parent-child relationships. So then what does my DFS look like? I would just at least run through it before I committed myself to like some pseudocode. That's at least the way I would do it, just to make sure my idea is kosher and I have some idea of how it actually works. Because the moment you start like doing the pseudocode for this is the moment you start carrying around these ideas and carrying some weight around, and it's just like it kind of starts slowing you down because oh well, I realize this doesn't work. Let me try it again. Let me try it again. If you have like a vague idea of what you want to do, that fills in like 80% of the pseudocode for you right there. And the last 20% is like, oh yeah, let me fix this one little thing I forgot and overlooked and retry.
Okay.
It's about reducing the amount of work that you need to do, and I'm assuming this is going to take you another 10 minutes to fill out, go back and forth on. Let's see.
So cool, that function call return.
Yes. Okay. So you go here, scrolling back and forth, trying it out. Note K.
Oh my. No, he does not have a child, right? So okay, now we're choosing the condition of like where we want the although I know previously before, like when we did when he has no
Back.
child, like all we had to do like didn't matter where we ended it, right? Because essentially speaking, like we didn't have to
Rather close it. Okay. Sure. Yeah.
But let's just
Okay, so I like the idea that you're doing the stack trace here to keep track of the variables. Keep in mind, result is probably a global variable, so you can keep it outside the stack trace.
Oh, okay.
Yeah, because that is like carrying it through, because this is technically a reference.
Okay. I think I'll just keeping it there because like what made this and I keep kind of just saying like what made this problem difficult, but it was just like there's so much to kind of like keep track of, you know, it's like comma and that. So I think I was putting the result there just to yeah.
The reason why there's so much to keep track of is because you didn't try running through the idea. It's because you are doing it haphazardly. You're kind of slapping on things and then hoping they stick, and then and you're not really sure how it fits in the bigger context of the problem. All you know is that it works. That it works like, or at least it appears to work. And that's kind of like what I see here is that because you didn't run through that one whole problem, like just on an idea, just like, hey, does this actually work? Did a cursory check? That's kind of leading to like this whole mental weight that you have of like, oh, well, there's so many things to keep track of.
Okay.
So I would recommend you do that. So let me write that down for you. Because again, we want to get to this idea where we can just like do things automatically in our head and then do the pseudocode to reflect the idea. So I'm fine with this. Okay, so you're finishing up. I would say here at this point, I would be fairly confident like that the example works. Because you've already gone through like one leg of the tree. You don't need to go to the second because it's more or less the same thing, I think.
Yeah, I think I was just really if you see in the result it's skewed a little bit, like the C has like the parentheses, so that's kind of when I realized like, oh, I still need to edit it more for the pseudocode, but
okay.
I guess
okay, that's fine.
Yeah.
Let's see what happens. What more do you edit here? The C is skewed, but it's like, I mean, that's okay.
Okay.
It's like, because C doesn't have any children, right? So why does C have this? Because C is not going to enter the children. I mean, you can still keep going. If you want to double check C, I'm fine with that. But it's like, to me...
there's supposed to be a comma after the C.
Oh, is there?
Yeah. Because, like, it's part of, like, a greater... like, D's supposed to come after it, essentially. Okay. So that's when I kind of realized, like, oh, I'm placing the results part in the code, like, wrong.
Okay, but... Oh, is it because you ran through the stack trace wrong?
Yeah.
Yeah, okay, you did the stack trace wrong then. Okay. Okay, that's you like checking like, hey, wait, why is this C? That's fine. I think this is fine. It just means that you fucked up somewhere on the it's a mechanical error. But again, I think this could have been avoided if you had just tried running through the code.
Okay.
Like at least like the idea first. This to me, if something like this comes up, like something that's like a careless mistake, it usually means of two things. One, you're not paying attention, but I think you're paying full attention here. The other thing is that you could have had like a better idea of what you're doing going in. Because usually careless mistakes like these that are avoidable are usually caused by doing things on the fly. You know, like I don't do things well on the fly at all. So it's like going in with a little bit more preparation. So that's what this is telling me. Okay, so I'm gonna just skip ahead because it's just you trying to, I think, debug the where you went wrong.
Yeah, I took like a quick bathroom break, I think.
Okay, yeah, this is like one long ass bathroom break. It's like 7 minutes.
Yeah.
All right. So I count 7 minutes off. Fine, whatever.
Alrighty, you're back. So let's continue.
Okay, it's fine. 20.
Alright, so now we're at like, go through it, and the result plus equals a no down. We have I and then.
Okay. Yeah. That parenthesis I would be saying is up as a flag. So definitely would not have continued. I would have stopped there and said, "Fuck, what's going on? Why is this not right?" Because you already, like you said, you already have the answer, right? So you already know what you're looking for. One, like the fact that this is
of where the result was going to be. Like I think it was a mechanical issue. So then like,
yeah. But if you ever run into this problem again, if you ever run into this issue where it's like, hey, this is not matching up with what's going on in my head, I would take a few seconds to understand why. Is it the idea that I had in my head is wrong, or is the idea that I'm doing right now wrong? I would do that. I would ask that question right here.
Okay. I think what was going through my head at that moment was like, okay, like I feel like the solution I have right now isn't like entirely perfect. So, but it's close enough. So let me just keep running through it to see like where what I can do with what the final result will look like. Because and I know this is probably not like a good idea, but when I was looking through this, I was like, okay, like maybe my stuff's not going to look correct. And then I can edit it in the end using like another for loop or something like that. But thinking back on it now, it's I should have stopped right then and there and been like, okay, what's up with my code? Like, why am I putting it there?
Yeah, because I would argue that your the thing you proposed before was great. Like I think it works well. The problem here is like it doesn't match up. So if it'd be a different story if it's like, hey, I'm not quite sure if my answer is correct. That's a different thing, and I would say, okay, just keep pushing through, and then see what happens, and then there'll be like some matter of fact that pops up that will explicitly show, hey, yeah, you really fucked up by missing this detail or something. So.
Okay, but to your eye right now, it's like I kind of have the necessary components. It's just maybe cleaning up like the code.
It's more like, well, like I said, just run through the idea first. The other thing is like if you run to this issue, your idea, your result that you propose is super solid. There's no reason to doubt it. I think the question now is, well, what the heck is this double parenthesis? And so at this point, I would check it. I would like, why is this happening? I would pause and actually take a breather and try to figure out what the hell happened here.
Oh, okay.
That's the way I would do it.
But before that, actually, so every time we did like we're going to go
Fine.
to, oh no, we're just going to go to H. So H results is going to be equal to just after H return. And so red J doesn't have children, and so connect here, J returns a comma here, so.
Okay, here you're just I'm guessing that this is you debugging what the C and D happened. What C and D happened?
Yeah.
Okay, that's fine.
Exactly.
So basically, the mistake here, like you started like I think started writing things out at like 26, right? And so basically, it's a 12-minute mistake basically. I'm okay with you walking through the code. I'm okay with that, but it's like it's just 12 extra minutes of you walking through it. And I'm like, well. I feel like this could be kind of avoided. Like you didn't need 12 minutes of verification in my opinion. But that's I don't know. That's not super important at this point, because even if it's 12 minutes of verification, just make sure you go over every single detail. That's fine, because writing this code now that you have it's going to take like 5 minutes. So that's like what 17 minutes, and then that is half the time, and then you can spend the other half doing the deserialize or longer, or however long it takes. Yeah. Make sure you adjust this. Make sure it's okay. But then if you change this, you need to double check to make sure that nothing here gets fucked up. Because for instance, if C have no children, then you have an empty open close parenthesis here. So. Well, then again, if you say while children, but the thing is that actually. Yeah, while has children. Okay, I see. Never mind. You're fine. Yeah, so a lot of this boils down to verification, and then try to clean up. But the thing is that,
Okay. And now we're at node B. Just return.
oh, now I see why it's taking so long. So basically, you ran through your idea, you tested it, and then now you're trying to test it again. But then you're testing it while building out your code as well.
Yeah.
You're
yeah.
double effort. It's already double effort right here.
Yeah.
So
yeah.
the thing is that I would have been perfectly comfortable with the idea after I tested it out. I wouldn't do this. This is what's going to kill you at the end, I think. So you're going to spend another like 10, 15 minutes. So basically, bottom line, most of your inefficiency comes from like retesting and writing the code while testing and not running through the idea. That's it.
Okay.
So it's like getting more comfortable with the idea of knowing what things will look like and running through the idea before you even write a single line of code. That's it.
Got you. Yeah, I think I just really wasn't comfortable with I guess for lack of a better term, like how to solve the problem, because I think just the n-rary stuff like really tripped me up a little bit. Because it was like traditional DFS, you only have like 2 children, like kind of the problems. But for this one, I was just like blanking on like, oh shit, like there's 3 that we have to take care of. Like, and I think that's what, as you can see, I was like, oh, let's do BFS then.
Okay.
Stuff like that. So yeah, I think my initial idea just wasn't there. And that's kind of what led me to write down that like BFS template, and from BFS switch back to DFS like in the middle, like, and yeah, just doing the double effort, I think. Yeah.
Okay. So I'm going to tell you. So let me bring up your sheet. You're basically describing 2 things, and to me, it screams that you are more focused on delivering the answer instead of solving the problem. So what do I mean by this? So let's take the DFS, not DFS, but the situation described was like while children result plus equals to a parenthesis, right? And then you have recurse child or something, and then result plus equals to comma, and then and then close out with result plus equals to, right, like this, right? And I would do that for the result here, and then for every child I would do this, right? So the question now becomes, literally, how do you express this for every child? And to me, it doesn't matter. For instance, let's say it's a list of children, right? Then all it is going to be for child in children, right? And let's say it's a binary. Let's say it's a binary. Like then all I would do, let's say binary tree. Then I would say child equals to I would just say recurse node dot left, and then result plus equals comma, and then recurse node dot right, and then that's it. This is the way I would write it. And you notice here nothing substantially is different. You see, like, and all we did here was really just change what this idea was. It's an implementation thing that just changes like really quickly, but the overall spirit of the answer doesn't actually change at all.
Yeah, I think. Yeah.
Whatever.
Yeah. No.
So don't get hung up on the details. You kind of have the same problem the last guy did, actually. It's kind of uncanny, actually. You're both like on a very similar track. So let me go ahead and write that down. Yeah, let me write down the sheet. Don't be overly obsessed with the details. Solve the problem first. Let's see, solve the problem. Yeah, solve the problem. Get ahead of. Yeah, solve the problem. Follow the problem solving logically. Don't jump to the details. Just immediately off the bat. Right?
So like when you say solve the problem, I assume you mean just kind of like have an idea of like how the problem can be solved, right?
Yeah, have a vague idea. It's like this idea works. The question is, what does the implementation look like?
Right. So what does the implementation look like? Like that doesn't fall under like solve the problem necessarily, right?
No, it's a consequence of like, hey, I have an idea of how to solve the problem. The next question will be, hey, well, how am I gonna iterate through all of this stuff? How am I gonna handle it? And that's really like that's where pseudocode kicks in, right?
Mm-hmm.
So it's like, hey, I understand that I need to iterate, I need to do a DFS, and then for every single child, I am going to when I go to the children, I'm going to add an open parenthesis. I'm going to iterate through the child, delimitate them by commas, and then close out the parenthesis once I'm done iterating through the child, and I'll do this recursively. That's the super high level, vague idea, right? But then the next question is
solve the problem, right?
Yes.
Essentially.
And like that is an example of me solving the problem with a vague, naive solution, right? So the questions we're gonna be asking is like, okay, is this the most optimal way of doing it? Is there something faster? And then let's say that there isn't. Let's say that we think this is good enough because this is like an order n time solution. So then after that, it's gonna be look like okay, well, what exactly is a step-by-step gonna look like? And this is where pseudocode actually kicks in. And what you're doing is doing the reverse. You're trying to use the pseudocode to help you look at the details before you even understand what exactly you're doing.
Yeah.
So that's like kind of the issue here. And so I want to really what's it called? I want you to really stray away from this idea of going for the details first. Okay. And I want you to focus on going from problem to idea to solution. And then using the code to implement that idea.
Okay.
Does that make sense?
Yeah.
All right. So then with
that...
Go ahead.
Yeah. No, it was just, I definitely knew that, like, in the beginning. I was like, yeah, this shit is going to bite me in the ass right now. But, yeah, it starts ideating, like, yeah.
And the only reason I like could figure that out is because I've made like probably the same mistake in the past, and I kind of already have an understanding of like how this bites me as well. Like I've made like all the mistakes you're making, I've made as well. That's why I know like what the solution is. So don't feel too bad about it. It's just that it's just we learn from our mistakes here.
Okay.
So walk through the DFS problem, drop down, try logic and reason, how we can go for order serialization. Low key right now. Yep. So start ideating. So 4 minutes to try an idea, that's fine. I think that's fine. 4 minutes to try an idea, I'm okay. I'm not going to nitpick on that because there's bigger fish to fry.
This was an interesting point. At 11:33, like, I think the reason why it took like a long time for me to even consider DFS is I was like, I knew there was going to have some kind of like looping, right, involved. And then, like, I knew that in the looping, since we have to go down, right, to represent the relationship, I was like, oh, that's going to be a recursive call. And then, so I don't know. I just thought that was really interesting. Yeah, I was just like, dang, like the idea that I was like, oh, shit, is this very hesitant to try this right now. But yeah. So.
Literally, that boils down to your discomfort with recursion, actually. I think that's what it's telling me. Because like you avoided it because like, oh god, I don't want to deal with recursion. I don't want to do it. Like, it's one thing you don't want to do it if it doesn't solve the problem. It's another thing you don't want to do it because you're not comfortable with it. And for me, you're telling me that you are not comfortable with recursion, so that's a problem. And so that's why I think you need more practice with DFS. I would say try to do a little bit more of the EPI problems if you haven't done them for DFS.
Okay.
And then you like try to cram the VFS. So this is like 4 minutes. I would say 4 minutes of wasted effort. Edit pseudocode in accordance with example results. Sure. Typing or talking faster and then running through your logic after. Say, I think that this just comes from an unclear thought process as well. So it's not so much about talking. I think it's more about your thought process. That's the big one.
Okay.
How much pausing in between so much? Does it clear my own idea? How can I be more sure? Do I need to think more critically? Yes, so this should be good. You caught on to like there should be a red flag here. If you're like, so there might be a flag here. Something you can improve on. How did you get to this situation? That's the thing you want to really ask yourself. Why am I taking so long? Why do I not know? What's holding me up? Rewriting pseudocode, so it to me like that there's a connection between here, but between recursion and pausing between idea. You don't know how this looks like recursively. That's what I think it is.
Yeah, because I noticed that I was like, I was repeating the same pattern, I guess, when it came to like testing, right? Like I was testing, I was going back to pseudocode, testing again, going back to pseudocode, and I was just like, yeah, this is I've definitely recognized that essentially. So, yeah. So.
Okay.
Yeah.
But I think I've gone over the most points. I would say the rest of this is kind of irrelevant, but like everything we talked about, like being comfortable with DFS, not doing not relying on pseudocode in order to express your thoughts. Try to have the idea in your head to begin with before you enter the pseudocode, and that will actually pretty much clear up everything. But the thing is that you're just technically weak on DFS to begin with, so that's kind of a hard issue right there. Yeah, so I'm gonna say that with that, I think the replay. I don't think we need to go any more into the replay, but overall, I want you to really focus on DFS and to do the same thing, solve the problem, follow the problem logically. I would say also, yeah, this one's gonna be a good one too. Like everything that we talked about like before with don't get super hung up on your ideas, do the call stack. I liked that you were able to do it. Think about meaningful tests. We will go over meaningful tests later. Well, no, actually, I kind of introduced you to the idea of states, right?
Yeah.
Yeah, so keep that idea of states. States, keep testing. Yeah, try testing as well. But yeah, like definitely this is going to be what you really want to do. You want to be able to use the problem to drive the answer, not the code to drive the answer. And then let me take a look at your schedule. I don't think you have vacation this week, right?
No, yeah, that's vacation. I could cut it like shortish. Yeah.
Yeah.
7 months. Yeah. I can still do stuff during vacation.
Mm-hmm.
Is essentially what I'm trying to say. Yeah.
I think what would be interesting is if I'll connect you to the other guy, but it'd be interesting if since you two have very similar problems, it'd be easier. I think it'd be better if you two like bounce ideas off each other on how to solve it. It's like, hey, I have this issue. Did you have also this issue? It's like, oh yeah, but I solved it the XYZ way, and because Edbert told me this, and then both of you get more value out of each lesson. Where it's like, if you watch literally like the previous stream and earlier, I'm pretty much repeating very similar ideas between the two of you. So it's like if you two can like bounce ideas off each other and like relay what was said in the streaming session and coaching sessions, I think both of you get double value actually.
Okay.
Yeah.
Gotcha.
And also, it saved me from repeating myself as well. So.
Yeah. No, sorry about that.
No, it's okay. It's okay. It happens. Yeah. So I would say redo the DFS. So homework. I'm gonna say redo some DFS.
Okay. Do you think the DFS, like, do you have any like other problems other than grokking? I think. Like, the only reason I say that is because like some of the DFS problem like I've kind of done before. So like to kind of do it, like I like when we were talking about like solve the problem, it's like technically the problem's already been solved, Mm-hmm.
But it's like the way you're doing it is the issue. It's like, hey, you want to do a problem where you have a question and then you grow the idea without using pseudocode to guide it. So if you have to, then just do some leak code, DFS marked flagged questions as well.
Gotcha. Okay.
That's my suggestion. But yeah, I think we have 20 minutes left. Do you have let me see your practice diary actually.
Yeah, for the practice diary,
a little sparse.
I didn't add the wins yet, but
okay, let's see your losses. I don't see anything from 27th, so I assume that you didn't have anything.
No, yeah, this was pretty much the loss. Yeah, the serialize and deserialize.
Okay, and then what about? I think you want to show me like the 2 problems that you did.
Yeah, for sure. Let me pull up the Google Doc real fast. Just correlate that to grokking real fast. Path with given sequence is one of them. So let me pull this one path with given sequence. Sending first one to you in Zoom.
Okay. You send to me in Zoom. Got it. Let's see.
Yeah.
Okay. Paths with a given sequence, right?
Yeah, that's one of them, and.
Okay.
Let me pull up.
Oh, this is pretty easy. I'm not surprised you didn't. Yeah. Like I want you to do the high level algorithm like this, But I think I want you to run through the idea first and then write okay, but this is pretty easy. Okay.
Yeah. So yeah, that's why I was kind of wondering if there was like the leak code ones for that one.
I mean, wait, you said you did EPI DFS, right?
Yeah, EPI DFS
Anything with trees,
sure.
really. Yeah.
Yeah, there was one I did 4 days ago. Oh, EPI one, the compute the lowest common ancestor when nodes have parent
Yeah,
pointers.
we did that one. You could try it again if you want to take another crack at it. If you don't remember the solution.
I'm sorry. Wait, what'd you say?
Do you remember the solution to that, or do you not?
Compute the lowest common ancestor when nodes have parent pointers one.
Oh, well, I'm not with parent pointers. I haven't seen that one.
Or just lowest common ancestor. Yeah, I never managed to remember that, so I can do that one again.
Sure. Great.
Yeah.
Yeah, do that one. And then let's see, recursion. Yeah, recursion. Chapter 16 is gonna be a good one.
Okay.
Yeah, I'm sharing my screen. So like, yeah, actually, binary trees is gonna be maybe binary tree. Yeah, binary trees is a good one. Yeah, so chapter 10 binary trees is gonna be good.
Okay.
Yeah, binary trees and then recursion. There you go. And we say that's gonna be what we want to target. Yeah. You should still be. It's kind of like a repeat from last week, actually. Now that I'm looking at your calendar. DFS, yeah, depth first search and subsets, and yeah. So basically, you might need to redo some of the stuff from last week. What problems from? I'm looking at the what's it called? The scenarios. Let me pull that up. Yeah, I'm looking at the scenarios. Which column are you doing, by the way?
C0 and C1 are the columns that I actually write down in like code.
Okay.
And then C2 and C3, I believe, are the ones that just pseudocode.
Okay.
Yeah.
I want to say if you can spare the time, do the code for the C2. Do more C3. Do C3. And then there might be some problems in those chapters that aren't listed in the C0, C1, C2, C3 columns. And try those as well.
Okay.
Try some of the problems that aren't listed.
Mm-hmm. Okay. Yeah. I'll do that. I'll make so do so C0, C1, and C2. C1 and C2. An actual Python code, and then do C3 and any other problems in pseudocode, you said?
Sorry, you need to do what?
Do C3 and any other problems in pseudocode?
Yeah, like I do C3 and all the other problems in pseudocode is fine, although based on what I mean I think your code is okay. But I would say pseudocode and then try like maybe a few of them, like, hey, I want to try like maybe half of them, write some code for it, if possible, but like yeah. That's the way I would describe it.
Okay. When you mean like the repeat of like last week, it's more so like the problems, right?
Correct.
Like, okay, gotcha.
So, let me ask, for the problems that you did last week, it's like these are problems that we probably like the issue should have been handled, but I get the feeling you didn't do as many problems as you should have.
Yeah, I mean, I think it's more so like when we go back to, at least for this example, right, the serialized one, it's for the problems I did last week, I think like I kind of knew, I was familiar with the problem itself, right? Like I've done those before.
Mm-hmm.
And so as a result, it's like all I had to necessarily do was just apply the kind of testing format, right?
Mm-hmm.
And that helps like it's like you said, it's like as long as you know how to like kind of like solve a problem, then matching the code to it, like once you have the pattern down and you're testing, it becomes much easier to put down. So I think an area that like at least this highlighted is like, oh, can I just solve the problem, I guess, like thinking wise. Yeah.
Okay, I see. But I want you to instead of like trying to, I'm gonna say you're trying to brute force your way through it. I want you to gain this intuition of what recursion and DFS looks like. So I want you to do the problems, but this time don't ram like tests through it in order to get an answer. I want you to really try getting into an intuition by running an idea first.
Okay.
All right. Just see if that works.
Okay.
Okay. So let me go ahead and write that in your sheet.
Okay.
intuition. Okay. But that's everything from me. Is there anything else?
Not. Oh, this was just kind of in the back of my head when I was doing the serialized, new serialized. Like, I noticed it was like a leak code like hard. Is there anything in particular for hards that like does the fact that it took me like an hour like correspond to the fact that it's hard, or is it just like not really? It's just like, oh, you need to actually like solve the problem and stuff like that. Does that kind of make sense? My question.
Can you rephrase that? I kind of didn't get that.
Yeah. So when I think I'm trying to say is like, oh, like typically speaking, like the problems I've been doing are more so like medium or like easy, right?
Mhm.
And then I think as a result, I'm able to like, whether or not it's I've done the problem before and stuff like that. It's like I can do it like at least like much faster. But for this one, I was like, I couldn't even get to solve the problem.
Mm-hmm.
Right, that part. Is that kind of? Do you think that's kind of based off of like? Should that just be something I expect from hard problems?
I think from hard, like this is like I would still rate this as a medium problem because it's purely mechanical. It's not even that hard of a problem really. If you want hard problems, I can throw you hard problems if I like.
That wasn't my point. I think I was just asking like, oh, like yeah, this one just took a long time, and I was like, holy shit, like, yeah.
I would say do some hard problems. Like I think you're just taking it too easy on yourself. Maybe try some hard problems. See how that goes.
Okay. Yeah.
Yeah.
And do more problems. Okay.
Yeah, definitely do some of the harder problems as well.
Okay.
Yeah.
Okay. Yeah.
And then I'll connect you two on Discord. I think you two would definitely have good conversations.
Sounds good.
Yeah.
Yeah.
Is there any other questions? Is everything clear?
Yeah, everything's clear. Let me just look at the study plan schedule one more time just to make sure if I... Okay, so finish DFS from last week. Subsets. And when you want me to redo the problems, like, should I be recording and stuff like that? Or you think
when you do the problems, I want you to record one of them for... Like, I think that for you, I would say try to record a few. And then, like, just quick... Huh?
Of the redos?
Some of the redos, yeah. I think like some of the redos would be helpful. Some of the new problems as well.
Okay.
And I want you to like do what we did today. Like quickly look over it and ask yourself, I got fucked up here. Why did I fuck up? And then it's like kind of go back like maybe a few minutes and then see if you notice like a pattern in your thinking. Like, oh, why did I do this? Oh, because this happened. Why did I do this? Etc. Etc. And then you'll come to like a singular idea or some action that you did that fucked everything up.
Okay. And on that kind of topic, like, do you also want me to, am I allowed to like not record every problem I do, or just like some of them and stuff like that?
Just some of them.
Some of them? Okay. Got you. Yeah.
Mm-hmm.
Okay. That would really help with like cutting down on time. Yeah, I feel so.
Yeah, you don't need to do every single one. Just like a few, like, hey, I want to do a spot check.
Okay. Got you. So, okay. Got you. So only record a few. Okay. Makes sense.
Mm-hmm.
Sounds good.
Yeah.
Okay.
Okay,
yeah,
and I sent you a friend request on Discord actually, because apparently I need to do that in order to make a group DM. Okay.
Okay, give me a sec. Wait, what are you talking about right now?
I added you as a friend on Discord, so just if you accept the friend invite, it'll be a lot. Oh wait, yeah. Yeah, pending.
Yeah.
And then...
Yeah, we're friends now.
Cool, perfect. I will go ahead and link you guys up, and hopefully things happen.
Okay, got you. Sick. Yeah. I guess that's all from me. Just to summarize, keep doing the problems according to the study plan. Redo some of the DFS. There also no need to solve the problem first. Follow the problem solving logically. Don't jump to every detail, and then. There's no, I don't have to record every problem I do. Okay.
Just be like, hey, I'm feeling good. Let me record this, and and see if it makes a difference. Yeah.
Sounds good. All right. Thank you so much, Edbert.
All right, for sure.
Good night, man.
All right, talk to you later.
Talk to you later.
All right. I guess that's it for me. Are there any other questions from the crowd? Let's see. Hey, Edward, when you read programming books like Clean Code, how do you take notes on them? I saw one of your videos you took notes on, but I'm not sure what to write here. Actually, let me show you my notebook. I think it'd be interesting. way I do my notes is kind of weird, actually. So I just do I take the top level idea, actually. I don't know if you guys can see this. Maybe I need to expand my camera. Let me see. Yeah, I don't know if you guys can see this, but basically, if you look here, I just try to take, like, the high-level idea and then do, like, some short explanation of it. Like, usually when it comes to, like, these paragraphs, there's only, like, one or two ideas that they really want to convey. And then that's actually, like, that's really it. The rest is, like, I only write as much as it takes in order for me to really understand the idea of whatever they're trying to say here. So let me actually turn to another page. Yeah, this is, like, in general how I take notes. I know everyone else has different ways of doing it. So for instance, this one actually comes from what's called refactoring. So you can see, like, I actually write the name of the refactor, and then like the details on it, like what it's used for, why, and like how to actually do it. You know, it's like something very short that I can just like kind of flip open and look at it very quickly without having to read the book. You know, I can look at it at 10 seconds and say, oh yeah, I remember this, and I remember these mechanics. That's kind of like more or less the exact same idea here with clean code. So let me actually open this up. Like for instance, this unit test, right? I know my handwriting is not the best, but like you can see here, like I only keep like a few ideas from that chapter or each section. So I think that's kind of the way I do it, because I want to keep it as a quick reference, especially for these really important books. I don't want it to be something that, oh, I have to actually crack open the physical book, turn to the page, reread the entire chapter in order for me to get the idea. No, this is just meant to be like a condensed reference. And I open this up from time to time as well. Like these ideas, they don't really change. Is the student that just went off a college student, or is he someone that's actually hired as a software engineer? He's actually a software engineer. But with that, looks like there's no more questions from the crowd. Thank you everyone for watching. I will be I'll be live streaming again on Monday, Tuesday, Thursdays next week as well, 8 p.m. Pacific Standard Time, and then for Thursdays, 9 p.m. Pacific Standard Time. So thank you all for watching, and good night.